Our main presenter will be Derek Micholson, and I will leave it to Keith Bamford, who was very good at press ganging him to join us tonight, and he will introduce her.
Thanks, John. Press gang, I don't know. You just got to pay people enough, and they show up. So, glad to welcome everyone attending tonight for this presentation by Derek Micholson. Derek is the program lead for the Knowledge and Research Transfer Program here in Manitoba, and has just about completed his second season. The title of the presentation is Biology, Diagnosis, and Integrated Pest Management of Nosema. The impetus to get Derek to give this presentation was the extension alert that RRAA sent to us in mid-June. We thought it'd be great if Derek could present some information on this issue, which would allow us to ask questions and seek some clarification on how to manage Nosema. Derek will cover the biology, diagnosis, and integrated pest management of Nosema, which will include discussion of current registered treatments and an overview of some recent research into alternative treatments. And I think before he starts the Nosema presentation, Derek has agreed to give us a little briefing on a very important part of fall management, and that's Varroa mites. So we can welcome Derek.
Testing. Is that a pretty good volume? Too loud? Good. Okay, yeah. Thanks everybody for the invitation to speak to you guys again. It's nice to be back in person today and see all your friendly faces. So today, I was asked to speak on Nosema disease. As Keith mentioned, there was an alert put out by RRAA, just alerting basically the whole province about elevated levels that we were seeing this year. And that was, all part of the KRTP sampling program. I was going all over the province, and we were seeing pretty high levels this year. And so a lot of that is probably mostly due to the spring we had, and bees just being cramped in their boxes for so long and not being able to go on cleansing flights and that sort of thing. So it was kind of an anomaly year for that. Last year when we were doing our sampling, we were seeing averages of about 5 million spores per bee. That was kind of the province-wide average. And this year we were seeing upwards of about 15 million spores per bee. And we were really seeing, detrimental impacts on the colonies with that too, really struggling along in the springtime. But I think once the weather really changed and bees were able to kind of overcome that, they rebounded. And I've heard from not that many beekeepers, but the beekeepers I've talked to this year that seem to say that, their production was not too bad, but a lot of beekeepers had some lower numbers than they did last year. They weren't really able to regain their numbers, but the colonies that did produced fairly well, but probably slightly lower than average on the whole is sort of the initial impression I'm getting anyway. But we can maybe talk about that a little bit more later. So yeah, before I really continue on with the Nosema presentation, Keith also asked me to just touch on some Varroa management stuff. I know this is, still kind of early fall. We're already into mid-September, mind you. But if there's beekeepers out there that haven't started monitoring their colonies for Varroa, now would be absolutely the time to be doing that. Get out and sample your colonies, know what your mite levels are. It's still fairly early in the fall that, temperatures haven't really dropped substantially yet. And, your options are still, you still have quite a number of options in terms of treatments. The further we get into the fall and as temperatures start to drop, then those options are going to just become more and more limited. So just get out there and sample your colonies really and know your mite levels. I'll just touch on the fall thresholds, I guess, too, while I'm at it. Just so the early fall threshold is, according to Dr. Curry's research, is between 1% and 3% September 1st. So 3% is kind of that hard threshold where you should absolutely be treating your colonies. I think, you know, given the season we saw last year with the super extended fall and tons of brood in your colonies into October and even into November, that 3% is probably pushing it for an early fall threshold. You know, especially if we're going to be seeing more and more years like that in the future. So personally, I would probably lean more towards that 1 to 2%. It does kind of depend, you know, if you're a commercial beekeeper or a hobby beekeeper, that threshold was kind of designed for the amount of risk that each individual beekeeper wants to accept. So if you know, if you're a hobby beekeeper and you don't make your living off of beekeeping, then you might be willing to accept a bit higher of a risk, and your sort of your personal threshold might be in that 2% or 3% range. So that's kind of about it for that. Yeah, so and yeah, I'll just mention too that of course Rael is obviously not in his position anymore, but that honeybee health treatment guide that he sent around to all Manitoba beekeepers has all the information we need really on applying any of the Varroa treatments. So. Yeah, and I'll just mention too that the KRTP has a YouTube channel with a couple videos on it. It's specifically related to Varroa. So back in March, Rael, Dr. Curry and I, we put on an integrated pest management of Varroa virtual webinar and recorded that. So that's up on the YouTube channel. That one's about 2.5 hours long or so, but it's pretty in-depth. Dr. Curry speaks on biology, and I did some monitoring stuff, and then Rael talks about all the treatments. I also put out a Varroa kind of field monitoring video this summer, just more so just looking at those methods of monitoring actually in the field. So a couple videos up on YouTube in relation to Varroa. Also up on the KRTP webpage on the Manitoba Beekeepers Association site, so manitobabee.org/KRTP, you can find a PDF I put up there a while back, just with I compiled a whole list of Varroa mite resources. So you can check that out as well. And just one other thing I'll mention is that Paul Kozak, the provincial apiarist in Ontario, recently sent me an article they put out in Ontario. It's called Now or Never: Late Season Colony Management for Survival, Varroa Treatment Options, and the Importance of Timing. So this has a lot of really good information, and maybe I'll share that with John to disseminate to the group as well. That's a really good article. Okay, so we'll jump back into the Nosema presentation here. So yeah, so I'll kind of cover biology of Nosema, diagnosis, as well as integrated pest management. You know, there's fumagillin that you can use for treating for Nosema, but there are some other techniques and management type things you can be doing as well. Yeah, just before I get into this presentation, I'll just mention that just last week, I also published another YouTube video on Nosema disease as well that covers pretty much everything I'm going to be saying tonight. And so if you're interested, you can check that out as well. Okay, so Nosema biology, first of all, and the life cycle. So Nosema disease is caused by it's sort of a specialized group of spore-forming fungal parasites known as microsporidia. So these microsporidia are in the kingdom fungus, but it's kind of a specialized subgroup of fungus called microsporidia. There are two different species of Nosema that can infest the honeybee colony, Nosema apis and Nosema ceranae. So Nosema apis is historically the species that's been really well known in Canada and around the world, infesting European honeybee colonies. More recently, Nosema ceranae, coming from the Asian honeybee, has been found pretty much worldwide, and specifically in Canada, it's really actually taken over as the more dominant of the two species. with a lot of sampling and different research recently, we've really, been seeing Nosema ceranae has been found a lot more than Nosema apis, although both species are still out there and are able to infect a honeybee colony. So they do have a similar life cycle. So they are spore forming parasites. So these spores of Microsporidia are very hardy spores. They're really persistent, and they can linger on frames in your colonies and on the parts of the colony itself. But the worker bees ingest these spores usually through cleaning up fecal material in or around the colony. They can also pass spores from bee to bee via trophallaxis. But once these spores are ingested by the bee, they travel down to the gut of the bee, into the midgut, and they have this, it's called a polar filament. So it's kind of this like harpoon-like coil that's coiled inside the spore. And so once it's down inside the midgut, it basically releases this harpoon-like polar filament and basically penetrates the cells inside the gut of the bee and parasitizes the cell. So it kind of hijacks their energy and uses the cell to replicate. So it basically stabs into the cell and injects sporoplasm. And then the spores are able to reproduce inside the cell. And once there's a large number of spores that are reproducing in the cell, it'll burst open and burst all these new cells into the guts of the bees, which can then go on to infect more cells in the guts, or they may also be shed out in the feces of the bees. So Nosema is kind of a stress-related disease. It really amplifies in times of stress on the colonies. So this can be nutritional stress or overwintering. Bees used for pollination have also been seen to have higher levels of Nosema. And yeah, I'll jump to the next slide. So yeah, it's a stress-related disease. Again, yeah, nutritional stress, inclement weather, or even transportation can lead to elevated levels of Nosema. So the spore loads do generally peak in the springtime. So particularly with overwintering, when the bees are kind of cramped into the colonies and not able to go on these cleansing flights, the spore loads can really amplify over the winter. And both with Nosema apis and Nosema ceranae, the spore loads seem to peak in the springtime, although with Nosema ceranae, they seem to peak a little bit later than Nosema apis. So with both of these species, there are some very similar symptoms and impacts on the colonies, but there are some differences, which I'll get into later. But with both of these species, what you basically see is a reduced lifespan of the individual bees, and it can also accelerate the rate at which the bees age. It also has impacts on their development of their nursing glands. So basically, the bees are aging quicker. They're kind of bypassing through that brood rearing phase and basically going into the forager stage of their life a lot quicker. And it's also impacting their nursing glands, so they're not even able to tend to brood as well as they would be. So what you basically see in the springtime is just a really slow buildup of these colonies in the spring. It's they're stressed, they're not able to rear brood as effectively. And so colonies impacted with Nosema will basically just be slow to build up, and they may even start to kind of go backwards and depopulate as well. With either of these species, with an infection of either of the species, they're also more susceptible to secondary pathogens. In particular, black queen cell virus has been found to be more associated with Nosema infection. And so, with all these things, that basically leads to just a decrease in overall population of the colony and a decrease in overall productivity as you go into the honey flow. With Nosema apis, so Nosema apis is a lot more well-known and more studied historically. We're still learning a lot about Nosema ceranae, but historically there's some kind of common symptoms of Nosema apis. Now, I have asterisks beside each of these because they can also be, pop up due to other factors. So these symptoms are known to be associated with Nosema apis, but they may be caused by other factors as well. So fecal staining is kind of that classic symptom that most beekeepers affiliate with Nosema disease. You may also see the wings of the actual bees uncouple, and it's called K-wing, so the wings become uncoupled and they're kind of in the position of a K. You may also see some crawling bees kind of around the front of the hive. But again, all those symptoms can be affiliated with other factors as well. So really the only way to know if it's Nosema for sure is to sample your bees and either send them into a diagnostic lab or diagnose them yourselves and look for those actual Nosema spores under a microscope. And again, I mentioned that the peak with Nosema apis is in the early spring. With Nosema ceranae, basically none of those classic symptoms of Nosema apis are really noticed with Nosema ceranae. So we don't really see that classic fecal staining as we did with Nosema apis. So Nosema ceranae is also sometimes called dry nosema. Some people refer to it as a silent killer as well, because you don't really see visual impacts on the colony and other than the population sort of decreasing and decreasing. Nosema ceranae is known to be a more virulent species of Nosema, and we usually see a bit of a later peak, either into the late spring or even early summer with Nosema ceranae. Nosema can also impact queens. So the queens can be infected after they're fed by an infected worker. And once a queen becomes infected with Nosema, basically her egg laying is reduced and she may be superseded or she may even just die. So it can impact queens as well. And I think I saw that this springtime that a number of beekeepers reported to me seeing signs of a lot of queen supersedure this spring, which sort of made sense given their Nosema level. So that may or may not have been a factor there. So diagnosing Nosema, as I mentioned, really the only way to diagnose it is to actually sample your bees and have them diagnosed in the lab, or you can also do it yourself if you know how, but it's really not that hard, and I'll kind of walk you through the steps in this presentation. But when you're sampling your bees, typically the older bees in a colony are going to have higher levels of Nosema. They've had more time for those spores to really amplify in the guts. So it's recommended if you're going to be trying to diagnose Nosema to try to collect some of those older bees. So on the left-hand side here, this is just a picture of a bee vacuum. This is from Randy Oliver's site. I think he calls it the Suck-A-Bee. Basically, it's just kind of a handheld vacuum that's been modified to just collect a sample of bees. He's got a sample jar actually attached to the vacuum there. If you don't have one of those fancy vacuums, you could also just put like an entrance reducer or just a block of wood or something on the front of the hive, and any of those foragers coming back to the hive would just kind of build up on the front of the hive, and then you could sample off the front of the hive that way. Or you could just pull kind of one of the outer frames where you'd be more likely to find some older bees. It's typically recommended to collect between 60 to 100 bees to do a Nosema analysis. You can use fewer bees than that. I've seen some places recommend using 25 bees. The more bees that you use, your sample can be biased. If you have one really infected bee, your sample could be biased that way. So using sort of a larger number of bees gives you sort of a better picture of the overall infestation in the colony. There are other ways of doing it too. So, I mean, the way I'm going to show you is taking a whole sample of bees and getting basically an average spore load per bee in the colony. You can also look at individual bees and determine how many of those bees, say you looked at 10 bees and you found 5 or 6 bees that were infected with Nosema, you can sort of get look at how many bees in your colony are actually infected with Nosema and look at it kind of from that point of view. But generally, when people are doing a Nosema diagnosis, they're collecting a large number of bees and mashing them up and sort of doing this pooled sample and then calculating how many spores per bee are in that sample. So I'll just kind of explain the diagnosis and maybe this will sort of pique some people's interest of trying to do it yourself. This is kind of all covered in the video I put out up on YouTube as well. But basically for diagnosis, the main tools that you need are a microscope. You need a compound microscope capable of going up to 400 times magnification. That's the magnification that you need to actually see Nosema spores. You also need a mortar and pestle or some way of grinding up your bee sample. A syringe is very handy to be able to apply a certain amount of water. And then an eyedropper is also a very handy thing to have, as well as this special slide here. It's called a hemocytometer. And a hemocytometer is used typically for counting blood cells. It's very handy to also use it to count Nosema spores, and that's kind of the standardized way of doing it. And then you can apply a formula to calculate out how many spores per bee you're seeing. I'll explain that a little while longer, but this is kind of a close-up view of a hemocytometer. Basically, on both sides here, there's a little grid on either side of this hemocytometer. And so you mash up your bee sample in water and you put 1 drop of that slurry or soup onto each side of that hemocytometer. And then within that grid, once you're actually looking in a microscope, you can see that grid. You can count how many spores are in amongst that grid and then apply a formula. Microscopes, I find in talking to beekeepers, I think most beekeepers think microscopes are super expensive. They're probably maybe not as expensive as you might think. This is one that's found on microscope.com. This is known as the Beekeeper Special. This is recommended by Randy Oliver. It says right here, it's a really great microscope for doing Nosema analysis. I know Marg and Rob donated one to the KRTP, so this is one I've been using and I really like it. You can see the Nosema spores really well with this particular microscope. But you know, I've looked on Amazon and other places like that, and you can find even cheaper ones on Amazon. So yeah, maybe a little bit cheaper than you might think. So with diagnosis, this is just a little video from that YouTube video. Basically, you're using 1 milliliter of water per bee in your sample. So when I'm doing my Nosema samples, I'm using 100 bees and 100 mils of water. I grind up the sample. Usually I just add just a tiny little bit of water at first, just to kind of start it off. And then I'll add the rest of the water into that kind of mashed up sample. You could then take your soup, your bee soup here, and just pour it through some sort of a straining device just to strain out some of those larger bee parts and get a cleaner sample onto your slide. So this is basically what you're left with after you strain out those big bee parts. You can have this little brown soup here. Then you put 1 drop on each side of that hemocytometer. And then take your slide and throw it under a microscope. And basically this is what you would see when you looked in your microscope. So this would be kind of looking at basically the furthest out, the lowest zoom setting. And so on the hemocytometer, there's this grid. Basically there's 25 of these large squares in this grid. And then within each of those, larger squares, there's actually 16 smaller squares. You don't have to worry about those 16 smaller squares, just kind of focus on those large squares. And the typical recommendation is to just count how many spores you're seeing in 5 of those large squares on each side of the hemocytometer. So you're actually counting 10 large squares. So typically we count the square in the top left, the top right, bottom left, bottom right, and then the square in the middle. It's just kind of our standard way of doing it. So when you actually zoom in on one of these large squares, this is about what you would see. Depending on how clean your sample is that you've prepared, there are some sort of tricks you can use. You can dissect off and just kind of remove the abdomens and just crush up the abdomens to get a cleaner sample. You can also dissect out the guts of the bee and get a cleaner sample that way. But typically we're just crushing up the whole bee, and that's really sufficient for getting our counts. So this is basically what you would see in one of those larger squares. Now it's probably really hard to see here, but the Nosema spores are quite small, but they are sort of this characteristic rice shape, rice grain sort of shape. So there's one here, there's one here, there's one here. This isn't the best picture, I know, but we found a much better, much more highly infected sample in the springtime that had just tons of Nosema spores. So I think this was like somewhere around 50 or 60 million spores per bee when we did the calculation. So that was really infected, but you can see them a lot better in a slide like this. So this gives you a better idea of what they'll actually look like. But so if we kind of go back to this example, in this particular sample that we collected, if we were to count 10 of these large squares, so this would be one large square, we found 1, 2, 3 Nosema spores. So when we counted all 10, so this is one side of the hemocytometer here, 2 sides, so there's 10 large squares. So this, I'll just explain the formula that we use. It's very, very easy. Basically, you total up the number of spores you count in all 10 of those squares, divide it by 10 to get your average spore count per large square. And then you take your average spores per large square, multiply it by 250,000, and that gives you your average number of spores per bee. So quite simple. So with our particular sample there, we found 24 spores in our 10 large squares. So divide that by 10. We had 2.4 spores per large square, multiplied by 250,000, and we had about 600,000 spores per bee. Now the threshold for treating, it's sort of a bit of a contested topic, but currently the recommended threshold for treating is 1 million spores per bee, either in the springtime or in the fall time. That threshold may be adjusted at some point as more research is done, but some recent research that's come out of Guelph has basically not confirmed, but supported that threshold. So hasn't changed yet, but it could in the future. If you're doing a single bee analysis, so if you're crushing up each individual bee and looking at the percentage of how many bees are infected, the general threshold is if 50% of those bees are infected, you would want to treat for Nosema. Okay, so we'll just jump into controls and integrated pest management of Nosema. So first off, just to touch on the actual components of integrated pest management. So basically there's 4 components of IPM: awareness of the pest, monitoring and awareness of the thresholds, and implementing solutions. So we've basically already touched on the first 3. So into the solutions, there is, as I mentioned, the fumigillin treatment that everyone's probably aware of, but there's some other things that can be done. just trying to prevent the pest and increase your biosecurity in the first place and try to prevent nosema from really taking hold in your colonies. There's some other cultural and physical controls that can be utilized as well. And then of course the fumagillin treatment, and there has been some quite a lot of research done into some more alternative treatments, which I'll touch on at the end. So just looking at prevention and biosecurity. So first off, just beware of any used equipment that you're bringing into an operation. If you're buying a bunch of equipment from a beekeeper, you don't really know what's in that equipment. So you don't really know how long it's been sitting in storage. And so it may have some pretty high spore loads. As I mentioned, the spores are super hardy. They can persist on combs and on the side of the boxes and that sort of thing for quite a long time. So just beware of anytime you're buying used equipment. If you have any dead oats in your yard, it'd be a good idea to clean up those dead oats as soon as possible, get them out of your yard. You don't want to just leave them sitting there for the rest of your bees to come and rob out. You could be transferring spore loads that way. Providing clean feed and water source to your bees. That's another route of transmission of spores. Could be a contaminated food or water sources. And so sort of on that topic is just avoiding open or rob feeding. I know a lot of beekeepers do rob feeding. It's obviously much easier if you just fill a barrel and your bees can just go collect it and bring it back to their hives, but you can be transmitting spores to other hives in your colony, or even a neighboring yard or a neighboring beekeeper with that sort of feeding as well. So be a lot better just be feeding your colonies directly with buckets or hive top feeders or that sort of thing. The cultural and physical methods for nosema, basically reducing any other stressors of the hive. So as I mentioned, nosema does have a tendency to amplify in times of stress. So just trying to control all other pests and diseases in the colony can help to keep spore loads down. Queen problems, so keeping young and vigorous queens, especially in the springtime as that colony is growing in the spring. You don't want to have any queen problems kind of holding your colony back. Nutritional stress, so feeding supplemental nutrition, pollen patties and supplemental syrup can help with nosema. And wintering and spring stress. Research has found that indoor wintered colonies usually do a little bit better in terms of survival with nosema levels. In the springtime too, if you're wintering somewhere outside, it'd be beneficial if you had a good wintering site that's also a good spring site. Someplace that has a lot of sun, the bees can leave the colony a little bit earlier to go on those cleansing flights. It's recommended too to have some good air drainage. You don't want a site where in a low-lying area where you have this cold, moist air kind of pooling in one spot and preventing your bees from really getting over that spring stress. So it's also highly recommended to have some sort of a comb replacement system within your operation. So removing some of that old comb that's been in your operation for quite a while, usually on a period of 3 to 5 years, you should be removing some of that older comb and constantly putting new foundation into your colonies and letting them draw out some fresh wax. Disinfecting your equipment, it can be a way of actually reducing spore loads on your equipment. So there's been a lot of research done into things like electron beam irradiation. We used to have a place in Manitoba that would do it up in Pinawa, but that has to shut down basically. So there still is one site in BC that will do electron beam irradiation, but it would be obviously a little bit expensive to ship everything out there, but it may make sense for a larger beekeeper to ship a lot of equipment, or multiple beekeepers to kind of pool equipment together to ship stuff out there. fumigating with acetic acid has been shown to be able to reduce spore loads on your equipment. This isn't, regular acetic acid like vinegar. This is a really concentrated 80% acetic acid that you use. It's quite dangerous to use. There is a really good video by the University of Guelph that explains how to do that. So if you're interested, you can check out that video. Heat treatment, I put an asterisk on heat treatment there. We know that there has been research done into using heat to control Nosema apis spores, but with Nosema ceranae seems to have a higher tolerance for heat, so that heat treatment doesn't really work as well. The recommendation for Nosema apis was to maintain your building at 49 degrees for a period of 24 hours to control those spores. With Nosema ceranae, they seem to have a higher tolerance for heat, so you kind of run the risk if you're getting up there with your heat of actually melting all your wax. So heat treatment isn't really recommended for Nosema ceranae. Using resistant stock or resistant genetics, some stock out there can be partially resistant to Nosema. Don't ask me where to get that stock. I'm not sure exactly, but it could be something that a beekeeper yourself could look at your Nosema levels over time and keep selecting from the ones with lower spore loads, and you may be able to select for Nosema resistance that way. So treatment, so really the only registered treatment for Nosema is fumagillin. So fumagillin is an antibiotic, and so that's the only registered treatment in Canada. So as I mentioned, the threshold for treating is 1 million spores per bee, either in the spring or in the fall. I know a lot of beekeepers don't like to use antibiotics in their colonies, so they're okay with some higher spore loads. And oftentimes, if you're controlling everything else in your colony is really healthy, they can tolerate some higher spore loads. But if they do end up having, some other stressors impacting those colonies, 1 million spores per bee is basically that general recommended threshold. So it's really important when you do use fumagillin to follow the label directions as closely as you can. Fumagillin gets mixed into sugar syrup and then fed to colonies directly. You never want to be open feeding or rob feeding medicated syrup. That could lead to some colonies collecting a lot more medicated syrup than others, some colonies not collecting as much medicated syrup. So you have problems with actually controlling the dose that your hives are getting that way. So if you're going to be feeding medicated syrup, feed it directly on the colonies. There is also a 4-week withdrawal period. If you're feeding fumagillin in the springtime, you want to stop feeding medicated syrup at least 4 weeks before the main honey flow, before you're adding supers to your colony, or you could run the risk of contaminating your honey with the antibiotic. Honey from any of your brood chambers where you've treated with fumagillin should not be harvested. Yeah, that's a question.
You need a prescription for that?
Nope, that's available over the counter. Yep. Yeah, I'll just mention too that some of the research that came out of Dr. Curry's lab recently that he did with Rosanna Punko, she found that actually treating in the springtime was more successful in having the colonies actually survive the winter than actually treating in the fall time, which is a little bit counterintuitive. You would think that treating in the fall time going into winter would be more beneficial for actually increasing the survival. But with her study, she found that actually treating in the springtime was a better predictor of that colony going on to survive the winter. So I think that's kind of a novel finding, I guess, that she found in that study, and that more research should be done on that to see if that is repeated, but her study seemed to suggest that treating in the spring would be more beneficial than treating in the fall. Slide right on up. So so as I mentioned, nosema abundance in the spring was a better predictor of winter survival than the abundance in the fall. So treating in the springtime may be more beneficial. And she also found that indoor wintering actually improved survival across a range of spore loads versus outdoor wintering. So if you're wintering indoors, you actually may be able to mitigate some of those impacts of having some higher nosema levels. So wintering indoors was more beneficial than outdoors in her study. So I'll just kind of finish off with touching on some of the alternative controls. There has been quite a lot of research done into, using different things to control nosema, to try to move away from some antibiotics. Some of the ones that have been looked at are different extracts and different supplements. So I know a lot of beekeepers are using these in their colonies, and some of them, research does support that it can decrease spore loads. So that some of them that are out there, they're on the market, but they're probably not really doing anything. So one of them in particular that I'll mention, Nosevit. I know a lot of beekeepers have been using this, maybe not a lot, but some of them that I've talked to in the province. There was a study in 2014 by Higgies that found there was actually a reduction in colony spore loads with Nosevit. However, in 2016, a study by Vand and Heaver actually found there was no effect on spore loads. So pretty conflicting results there. So I will also mention that when I was doing some nosema sampling last year, a beekeeper had indicated that he had treated with Nosevit, and he ended up having the highest spore loads that I found in all of my sampling last year. So, not trying to poo-poo any products or promote any products, but just comment on the research and comment on some of my personal experience. Hive Alive is another product that is out there. That's a study in 2015 by Caristas found decreased spore loads as well as increased populations after using that product. So it may work, but I think we should be doing more and more research on some of these products. I know even with KRTP, we've talked about doing some more research, and in particular on Hive Alive with the KRTP. So that may be done in the future. Pre and probiotics have also been looked at. A study by Shane Klassen from the University of Guelph in 2021 looked at a whole bunch of different pre and probiotics, found that the prebiotics eugenol and naringenin and the probiotic protexin significantly reduced Nosema ceranae infection, as well as increased honey yields. And protexin also significantly increased bee populations as well. In 2019, Dan Borges, also from the University of Guelph, found also with naringenin that he found a 64% reduction in spore counts with his study. I just threw kind of a caution up on this slide. There was a study in 2016 by Ptaszynska, where bees were fed probiotic Lactobacillus rhamnosus, as well as a prebiotic inulin. And these bees were actually more susceptible to Nosema ceranae and actually had shorter lifespans. So again, if you're going to be putting anything into your colonies, try to do your research before you actually apply anything. Improperly selecting or feeding some of these pre or probiotics may actually do more harm than good, and may actually increase bee mortality. So just be really cautious if you're buying or using any of these products. Oxalic acid and formic acid have also been found to have some impacts on Nosema in colonies. Dr. Curry and Robin Underwood at the University of Manitoba in 2009 ran an indoor formic acid fumigation experiment, and they actually found lower spore loads over the course of 1 year. So formic acid may have some impact on spores as well. Oxalic acid was also found in a study in 2015. It was applied orally in a sugar syrup. The bees were actually ingesting it, and it was found to actually significantly reduce Nosema infection, as well as increase colony survival. So oxalic acid may have some impact as well. And yeah, there's probably plenty of others that I could have thrown up there, but I'll just mention that, that probably a bunch of other products out there claiming to have some impact on controlling Nosema that don't actually have any benefit on colonies. So really important just to, buyer beware and do your research before you're adding anything to your hives. And yeah, I'm going to leave it at that. So we can just open it up for questions.
We're also asking all of our web attendees.
Okay.
So Brad's going to, which we have 20 here, 20 of them.
Nice. That's not too bad.
Is any?
I have a logistic question. Like, so when you have your
I mean, we just usually collect them in a sample cup, and then by the time we get back to the live, they're dead in the sample jar. Yeah. So suffocation, or you can add alcohol and drown them. Yeah.
It was mentioned in over winter, you have a site where what if you decide that you know that the snow and the snow is
I guess it depends how early in the spring it is. Snow can have an insulating effect as well, but if you're getting later into the spring where it should be time for bees to get out flying, you might clear that to a lot.
I'm comparing the neighbors to the parents' hives where like the snow drifted over and let them when my bees are out of probably 2 weeks before the snow is gone from around the top.
Yeah, you might want to clear it out. Usually, the bees are able to get out and fly, even with some snow around the hive. They usually maintain an exit hole, so they should be able to get out. But clearing that snow off might help to get some sun rays actually on the hive and help it warm up, and might stimulate those bees to get out flying a bit earlier.
Just a logistical thing. People online probably can't hear.
Yeah, I was thinking that too. Maybe we should
might have to summarize the question before you answer it.
Yeah, or could we use the microphone, that microphone, to ask the questions? Would that be better?
We can run with this one.
Yeah. Next question. Mark?
Wait till you get the mic, please.
Okay, I have 2 questions. First of all, I know that you were encouraging people to send in samples this summer. Is it ever too late in the year to send in a sample and have it tested? Supposing that you're going through your hives now and you're finding some that are not doing too well.
Now would be a great time to send samples in. Yeah, KRTP is accepting samples. I will say we're pretty swamped at the moment when I'm doing a bunch of rural samples, so it might be better to actually send samples directly to the vet lab. But now would be a great time to be, looking at your Nosema levels and beekeepers are starting to think about feeding and probably already are feeding. So now would be a good time to know what your levels are.
Yeah, we had a big disaster over last winter and we don't want to repeat of that this year. So we're really quite skittish this year. The other question I have is, you mentioned that the spores live a long, long time. What do you do? What's the best thing to do with older equipment that you just don't know? Or is it possible to test that to find out whether the spores are there?
I know the Beaver Lodge Research Station has done some research on that, but I don't think they've really come up with a good technique
Except burning?
for doing it, like looking at the Nosema spores off, getting them off the comb and seeing how many are on the comb. I did have someone ask me that earlier this year, if we could send samples of our combs in and have them analyzed for spores. I don't think there's a very good technique established for that. But yeah, I mean, it's generally recommended just to remove older combs, as they're 3 to 5 years old, remove them from your colonies and just always be bringing in fresh combs to your colony.
So it's better to burn them.
Yeah, just remove them and burn them. Yeah.
Okay.
Next question.
She's gonna bring the mic to the back there.
Thanks. I'm wondering if I can ask you about your RRAA testing.
Sure.
Randy Oliver did a series on alternate solutions for doing the assessment. And I'm wondering if you had any experience with those alternative solutions.
Not sure exactly what you mean by the alternatives, like in terms of monitoring.
Yeah. So he used standard isopropyl alcohol, then also used windshield washer solutions.
Yeah.
Just detergent.
Soap, yeah.
And some lab grade stuff as well. I guess you answered my question.
Yeah, I mean, I guess my comment on that would, you could use any of those 3 things. The main thing is just be monitoring with any of those solutions, but like some of the isopropyl or ethanol alcohol would be a lot more expensive. You can reuse it, so it might be worth investing in some using your operation. But something like windshield washer fluid works really well. You do want to get like the winter windshield washer fluid, something with some alcohol in it. There are some winter windshield washer fluids out there with bug wash that have detergent in them. I find those ones really foam up way too much and they make it really hard to actually count the mites. And I've found that with dish soap as well. It's kind of hard to get the proper amount of dish soap into your solution. Add too much, it's just going to foam up on you. But I'm sure he has a recommendation on his website for how much to add.
It said 2%.
Yeah.
The ultra raw.
Yeah.
And I've tried it.
Yeah, it's not much.
Not much, any more than that. But
Yeah.
I tried it, I just was 40. Anyways, I'm just wondering if you're saying that those all of those would be satisfactory.
Yeah, any of those would really work. Yeah.
Laura?
I've been using a microscope looking at the spores. Nosema spores, and I can't really, they fluoresce, but I can't tell the difference between them.
Between the species?
Yeah.
Yeah, that's very difficult. I can't either. Yeah, they virtually look almost identical. Nosema serranae, I think, is a little bit smaller, but I'm not good at. Yep. Yeah. Yeah, I mean, if you want to know which species you have, that's usually done with a PCR analysis. So the lab in Winnipeg will do that. You could also send your sample to the NBDC in Alberta, and they can do that too.
Derek,
Yeah.
your formula, you had the 250,000. What's the significance of that?
That's just sort of the standard that's been established through studies. I mean, you have basically a standardized thickness of your soup, I guess, under your slide. So it's just they've come up with that standard. Yeah. Yeah, Brad.
Throwing back to the fluids that we use to test for RRAA. One that I never hear talked about is methyl hydrate. I've used that. What's your opinion, or do you have one?
I've never used that. Did you say you've used it?
I use it all the time. It's fairly cheap. I use it in my woodworking sometimes, so I have it by the gallon. It's easy to find, not hard to find, expensive like isopropyl. I don't know if there's any difference.
Where do you get it?
Hardware store.
I'm sure it's fine. I mean, yeah, it's got alcohol in it, right? And
Yeah.
yeah.
I don't know what kind of alcohol that is. It's wood alcohol.
Yeah. Yeah, you could do a wash, yeah, from the same colony, try each solution out and see. But I mean, with any of them, it's always recommended if you do it once, do it again, because you're probably going to find more mites the second time. And you could strain out your fluid and strain those mites out, and then add some more fluid and shake it again. Just make sure you got them all.
I've had variety of results. I've had 16 mites per 100. I've had 2. So I'm only assuming that that might works.
Yeah.
That's all I have to wonder.
Yeah, I'm sure it does. I've never used it, and that's the first I've
I
heard.
never hear mentioned this.
Yeah.
I always feel like my questions are so silly, but I'm gonna ask anyway. But so if you get a hive tested that was a dead out and it wasn't Nosema, you know, the word dysentery is always thrown around pretty freely. Can you explain that? And like, is that an assumption? Like, I won't even tell you what I think it is because I want to hear what you say about it.
Yeah, I mean, dysentery can be caused by other factors. In particular, poor quality feed can cause dysentery. I know Rob Curry's found in some studies that just the colonies that were treated with amitraz, so apivar, versus colonies that weren't treated with apivar had higher levels of dysentery as well. So things like that, and I think some viruses can lead to dysentery as well. So yeah, there's other things that can lead to dysentery. It's not always Nosema.
I just have a comment, not so much of a question. Maybe you can enlighten us about it. Randy Oliver had an article published several years ago in American Bee Journal, and he exposed actually equipment late October to UV rays from the sun. It has destroyed all the prevalent surface availability of all the bacteria that was there.
Of Nosema spores?
Yes.
Yeah. Yeah, I honestly haven't seen that study or heard of, I don't think I've heard of UV rays being used. So he just left them out in the sun, or?
Yep.
Yeah.
And I've been doing this for a significant period of time on and off with the yards, where I take all the boxes, replace them with fresh ones, scrape them, wash them, and just leave them baking in the sun and never use them again. It's actually a very old European way to restart your operation in the springtime. Another question I have is, you mentioned fresh food in the springtime and paddies. Is that not counteractive if it's too early? Because this is kind of a general statement. If they're not had a cleansing flight and the gut is full, and you're adding liquids to it, and a substance that is not natural, a matter of a patty, would not be actually something that will add to it.
Yeah, that's a good point. Yeah, probably more beneficial to be feeding protein and pollen in the springtime versus this, the liquid feed earlier in the springtime. Just get them going, and then be feeding sugar syrup a little bit later. Yeah. Yeah, and two, just with some some protein supplements, if they do have actual real pollen in there, I know it's beneficial to have that to be irradiated pollen, because there could be spores within that pollen as well. So yeah, be something to look for if you're buying protein source with actual real pollen in there. Just make sure it's irradiated.
So my approach is just categorize pollen, how you add it not to the stuff that are actually made out of plants from very often.
Yeah, I'll have to think on that. Maybe we can.
I'm just saying this because I'm watching many watching that very early in springtime, start off early in order to get it done. But actually backfires. If you actually wait a little bit longer, a couple of weeks, then you can actually give it and stop. But you can already make it all fancy.
Yeah.
That actually has a big effect.
Yeah. Yeah. Good point.
I find that in general, they not see people with that fails on sensors most time. So that kind of
Yeah. Yeah, it's not doing a lot of reading and stuff preparing this presentation. Yeah, it's not something that I came across in any stuff that I looked at, but yeah, it's a really good point. It's possible, but they're not registered treatments. I think they need more research done into actually looking at what dose to give and developing an actual treatment around those products.
Question over here.
Just two questions. First question is the basics. How often you do the mic check? I did it 2.5 weeks ago. Is this time for now or every month or what?
So what were your levels 2.5 weeks ago?
0.
And you haven't checked again yet? Yeah, I would check again. Yeah, check again and then check again later. Yeah.
Okay. The other question is about fumigillin. I don't feel I'm gonna test, right? Is it a good idea? I've heard from old beekeepers to just do it. Just put it into your syrup and just give it to them.
I think anytime you're adding antibiotics, you should probably know what the background is before you apply any antibiotics. I know that's kind of the common practice for a lot of people, is to just treat, but much more beneficial is to know what's going on. So that would be my recommendation. If you have no nosema, you're just kind of throwing money away and you don't need to be treating. Testing, I think at the vet lab, a test for nosema is only about $20 a sample. So, and you can kind of do a pooled sample in a yard. You can take a few bees from 10 hives or so and just send one sample in just to get just a general idea of what your levels might be in the yard. So you do it pretty cheap, or send me a sample.
If there isn't any more questions, going Thank you. Laura? Grab the Baltimore mic. It's just that the people online can't hear the questions.
Fumagillin, is it actually eliminating spores or is it actually killing off the sick bees?
Yeah,
Because with Nosema, it's exactly what it does.
Yeah.
It actually kills off the sick bees,
right.
eliminates actually the spores.
Yeah, I've read that too.
Fumagillin, actually, I don't know. That's my question for you.
Yeah, it doesn't kill the spores. It kills sort of the active phase of the life when they're actually, uncoiling that polar filament, and it'll sort of attack that phase of the Nosema life cycle and prevent the spores from increasing in the guts of the bee, but it won't actually kill the actual spore.
Will it then prevent spread?
It will be able to suppress your Nosema levels through not allowing them to increase.
I guess my thought is if it suppresses and a bee still is alive and eats the next bee, is actually capable of passing on?
It could be, yeah, you could still be passing spores on. But that's sort of how the antibiotic works, is to have that suppression effect and not actually kill the actual spore.
So Fumagillin was actually taken off the market, right? Because it had no effect on Serrana at that point in time. And it came back again because there was enough pressure from the beekeepers. Is it actually doing something right now?
Well, I don't know if it was taken off the market because it wasn't having an effect on Serrana. It was taking off the market because they stopped producing it, and then Canadian Honey Council took it over, and it's being produced again. And sorry, what was the question?
Is it still has an effect on
Yeah, as far as I've read, and as far as I know, it does have an effect on both species. I think we are still learning a lot about Nosema serranae, but I think one thing that has been shown is it does have an effect on both species. I think there's still a lot more to learn about Nosema serranae.
Because I remember actually Real being there, and one of his presentation said it had very little effect on Serrana. So I'm just kind of curious if there's different outcomes by now.
Yeah, I mean,
as you had several presentations, then one will find one thing, the other one will find the other. So it depends who paid for it, I guess.
Yeah. I know in his honeybee health treatment guide, it is stated in there that it does work on both species. So maybe that was updated from an older presentation, or maybe there's research that I haven't seen where it was shown not to work on Serrana. But yeah, as far as I know, it works on both species.
Okay, we're going to cap it there. Thank you very much.
No problem.